Okay, so I'm now recording a third and probably final lecture on logic, especially classical logic. So we talked about implication, equivalence, negation, conjunction and disjunction, and I already showed to you that implication can be expressed by negation and disjunction combined together. But how about equivalence? Well, think about it. Let's say we have two statements A and B. If both of them are true, then they are equivalent. And if both of them are false, they are equivalent. So if we say that both of them are true, then we can say the conjunction A and B must be true. And if this conjunction A and B must be true, then from this follows that A and B are logically equivalent. So the equivalence is an implication of the conjunction. And at the same time, we know that if A is false and B is false, then also A and B are logically equivalent. So not A and not B, or let's say the conjunction of not A and not B, the conjunction of the negations of A and B, also implies equivalence of A and B. Well, and on the other hand, the equivalence of A and B, what does it imply? It implies that there are two possibilities. One is that the conjunction of A and B is true, or the conjunction of not A and not B actually is also that A and B, both of them are false. So not A and not B returns true. So we actually have three implications. We said A and B implies equivalence. We say not A and not B implies equivalence. And we also say that equivalence implies that at least one of these two statements are true. So how can we express at least one of the two statements must be true? Well, is it disjunction. So statement 1 or statement 2. So statement 1 being A and B, statement 2 being not A and not B. So making this disjunction of these two statements implies equivalence, and equivalence implies disjunction of these two statements. So that means that equivalence is equivalent to the disjunction of these two statements. So maybe I'm puzzling you, but you can sit down and try to calculate it yourself, the way you calculated mathematical assignments at school, and you will see I'm right. So actually, when we say the conjunction of not A and not B, isn't it that this also has an equivalent form as a disjunction? Well, if we say A or B, then if A and B are false, then this is also false. Otherwise, it is true. So, the negation of this disjunction actually becomes true if both A and B are false. So we can also say, instead of the conjunction of not A and not B, we make the negation of the disjunction of A and B. So this is also another way to write logical equivalence using just negation, disjunction and conjunction. And also about implication, just think of it. If we have A implies B is the same as not A or B, and B implies A would be the not B or A. Well, what does it say about equivalence? Just think about it. Just think about it. Write it down, calculate. I cordially invite you to doing this. So have fun with logic. See you in the next lecture in case I'm going to do one. See you. Have a nice day.